Chapter 20, Section 2, Interactive Reader, pages 301 through 306, worth 23 points. Water in the atmosphere. Clouds and fog. Key ideas. As you read this section, keep these questions in mind. What conditions are necessary for clouds to form? What are the four processes of cooling that can lead to the formation of clouds? What are the characteristics of the three major types of clouds? What are four ways in which fog can form? Page 301. What is the condensation nucleus in this figure? What are four ways that air cools enough for clouds to form? How do clouds form? Highlight. A cloud is a collection of water droplets or ice crystals in the air. Continue highlighting. A cloud forms when water vapor condenses around small particles in the air. Continue highlighting. These particles are called condensation nuclei, singular, condensation nucleus. The troposphere contains millions of tiny particles that act as condensation nuclei. Highlight. They may be particles of dust, ice, or salt suspended in the air. On the left, salt crystal, water vapor molecules. On the right, water droplet. Under the diagram, highlight. Water molecules condense around the salt crystal. More water molecules condense around the original small droplet. Question number 1, what is the condensation nucleus in this figure? Answer, a salt crystal. A salt crystal. Highlight. In order for clouds to form, the air must be saturated with water vapor. Continue highlighting. The air is saturated with water vapor when it has reached its dew point. Remember that when the temperature drops below the dew point, water droplets can form. These droplets condense around the condensation nuclei. Therefore, in order for clouds to form, the air's temperature must drop below its dew point. Highlight. There are four ways that air cools enough that clouds form. Continue highlighting. Adiabatic cooling, mixing, lifting, and an advective cooling. Question number 2. What are the four ways that air cools enough for clouds to form? Adiabatic cooling, mixing, lifting, advective lifting. Again, adiabatic cooling, mixing, lifting, advective lifting. Page 302. Why does air cool when it rises? What is the condensation level in this figure? How does adiabatic cooling cause clouds to form? Highlight. As a body of air rises, the atmospheric pressure on it decreases. Continue highlighting. Because of the lower pressure, the molecules in the body of air move farther apart. Continue highlighting. Therefore, fewer molecules collide with each other and the air becomes cooler. Continue highlighting. This process is called adiabatic cooling. Continue highlighting. The air close to Earth is warmer and less dense than the air high in the atmosphere. Continue highlighting. Therefore, the air close to Earth rises. As it rises, it becomes cooler because of adiabatic cooling. Highlight. When it cools below the dew point, the vapor in the air condenses and clouds form. Continue highlighting. The altitude at which this happens is called the condensation level. in the figure on the right-hand side, rising, expanding, cooling air. Toward the top, dew point. Toward the middle, dew point. Toward the bottom, dew point. The bottom dew point is 12 degrees Celsius. The middle dew point is 11 degrees Celsius. And the top dew point is 10 degrees Celsius. The air temperature is shown in the middle, or above each dew point. At the bottom, it's 20 degrees Celsius. As it rises to the middle, it's 15 degrees Celsius. At the top, it's 10 degrees Celsius, at which point it reaches dew point. So in the figure, the temperature and the dew point are the same at an altitude of, highlight, 1,000 meters. Above that altitude, condensation begins and clouds form. Question number 3, why does air cool when it rises? Answer, there is lower pressure causing fewer. There is lower pressure causing fewer particles to collide with one another. Particles to collide with one another, cooling the air. Cooling the air. Again, there is lower pressure causing fewer particles to collide with one another, cooling the air. Question number 4. What is the condensation level in the figure? If you look on the left-hand side, where dew point is reached at 10 degrees Celsius and 10 degrees Celsius, the answer to the question is 1,000 meters. 1,000 meters. How does mixing cause clouds to form? Highlight. Some clouds form when two bodies of moist air mix together. If the two bodies of air have different temperatures, the mixing will cause the temperature of the air to change. Highlight. The mixed body of air may cool to below its dew point. Continue highlight. When that happens, clouds form. How does lifting cause clouds to form? Highlight. When air is forced to rise, it expands and cools. Continue highlighting. If it cools below its dew point, clouds will form. There are two main situations that force air to rise. Highlight. First, a moving body of air can meet sloping ground, such as a mountain. When this happens, the air will be forced upward. Highlight. Second, a body of cold, dense air can push a less dense body of air upward. Continue highlighting. When this happens, storm clouds often form. Page 303. When does advective cooling occur? What shape is a stratus cloud? What are the clouds in this picture made of? How does advective cooling cause clouds to form? Highlight. When a body of air moves over a cold surface, the cold surface absorbs the heat from the air. Continue highlighting. This causes the air to cool. Continue highlighting. If the temperature of the air falls below its dew point, clouds can form. This process is called advective cooling. Question 5. When does advective cooling occur? Answer. When a body of air moves over a cold surface. When a body of air moves over a cold surface which absorbs heat from the air. Which absorbs heat from the air. Again, when a body of air moves over a cold surface which absorbs heat from the air. How do scientists classify clouds? Highlight. Clouds are classified by shape and by altitude. The three main cloud shapes are, highlight, stratus clouds, cirrus clouds, and cumulus clouds. Stratus clouds. Highlight. A stratus cloud is relatively thin and flat. The word stratus means highlight, sheet-like. Continue highlighting. Stratus clouds form when a layer of warm, moist air lies above a layer of cool air. Continue highlighting. When the warm air reaches its dew point, wide stratus clouds form. Continue highlighting. Stratus clouds cover large areas of sky and often block out the sun. Very little precipitation falls from most types of stratus clouds. However, highlight, nimbostratus clouds can cause heavy precipitation. Question 6. What shape is a stratus cloud? Thin and flat, sheet-like. Thin and flat, sheet-like. Cirrus clouds. Highlight. A cirrus cloud looks like it's made of thin strands. Cirrus clouds form at altitudes about above 6,000 meters. Because the air is so cold at such high altitudes, highlight, cirrus clouds are made of ice crystals. Continue highlighting. Because cirrus clouds are thin, light can pass through them easily. Under the diagram, these wispy cirrus clouds form high in the atmosphere. Question 7. What are the clouds in this picture made of? Answer, ice crystals. Ice crystals. Page 304. What is the main way these cumulus clouds are different from cirrus clouds on the previous page? At what altitude would a cirrostratus cloud probably be found? Cumulus clouds. Highlight. A cumulus cloud has a dark bottom and a puffy top that looks like a cotton ball. The word highlight, cumulus, means piled. Cumulus clouds form when, highlight, warm, moist air rises and cools. As the cooling air reaches its dew point, clouds form. Highlight. On hot, humid days, cumulus clouds can be very tall. High, highlight, storm clouds called cumulonimbus clouds can form. The prefix, highlight, nimbo, and the suffix, highlight, nimbus, mean rain. Highlight. Cumulonimbus clouds often form before a thunderstorm. Under the diagram, highlight. These fluffy cumulus clouds look like cotton balls in the sky. Question number 8. What is the main way these cumulus clouds are different from cirrus clouds on the previous page? Cumulus clouds are puffy. Cumulus clouds are puffy. Cirrus clouds are thin and wispy. Cirrus clouds are thin and wispy. Altitude and cloud types. Highlight. Scientists also classify clouds by their altitude or height. There are 3 main altitude groups: low clouds, middle clouds, and high clouds. Scientists use prefixes to indicate the height of a cloud. The table below summarizes the three different altitude groups. On the left, highlight low. In the center, highlight 0 to 2,000 meters. Under prefix, highlight strato. Example, stratocumulus. On the left, highlight middle. In the second, highlight 2,000 to 6,000 meters. On the right, under prefix, highlight alto. Example, altostratus. On the left, highlight high. In the center, highlight above 6,000 meters. On the right, highlight cirro. Example, cirrocumulus. You can understand a lot about a cloud by its name. For example, you can divide the word cirrostratus into the prefix cirro and the root stratus. Highlight. The prefix shows that the cirrostratus cloud must have a high altitude. Continue highlighting. The stratus root shows that it is relatively thin and flat. The figure on the next page shows several different types of clouds. Page 305. Which two clouds in the figure probably produce a lot of precipitation? Why might advection fog and advective cooling share the same root? Under the diagram, scientists classify clouds according to their altitudes and shapes. The name of a cloud can give you clues about what type of cloud it is. At 8,000 meters, you have cirrocumulus. Between 6,000 and 8,000 meters on the diagram, you have cirrostratus. Between 4,000 and 6,000 meters on the diagram, you have altostratus. Between 2,000 and 4,000 meters on the diagram, you have both cumulus and altocumulus. Between 0 and 2,000 meters, you have stratus, you have stratocumulus, and you have nimbostratus. Highlight the word nimbostratus. On the right-hand side, starting below 2,000 meters and ending above or almost to 6,000 meters, would be cumulonimbus. Highlight the word cumulonimbus. Question 10. Which two clouds in the figure probably produce a lot of precipitation? Answer, cumulonimbus, cumulonimbus, and nimbostratus. Nimbostratus. Cumulonimbus and nimbostratus. How does fog form? Highlight. Fog is similar to clouds because it forms when water vapor in the air condenses. However, highlight. Fog forms very near the Earth's surface. The table below describes 4 types of fog and how they form. On the left, highlight radiation fog. In the center, highlight the ground becomes cooler at night, so the air near the ground cools. The description, thickest in valleys because dense cold air sinks. Thick around cities because water condenses on dust and smoke particles. Second row, advection fog. Highlight advection fog. Highlight the cause. Warm, moist air moves across a cool surface. Description, forms along coasts because the air over water is cooler than the air over the land. Upslope fog. Air rises and cools as it passes along sloping land, forms near mountains and other sloping land. Steam fog. Cool air moves over a warm body of water, forms over rivers and other bodies of water. Question 11. Why might advection fog and advective cooling share the same root? Answer. Warm air moves over a cool surface. Warm air moves over a cool surface. Page 306. In your own words, describe adiabatic cooling. Why must the air drop below its dew point for clouds to form? What are two situations that can cause lifting? Fill in the spaces in the table to describe different types of clouds. How is radiation fog different from advection fog? Question number 1, answer can be found on page 302. Air rises. Air rises. Fewer particles run into one another. Fewer particles run into one another, which means the air will cool. Which means the air will cool. Again, air rises, fewer particles run into one another, which means the air will cool. Question number 2, answer can be found on page 301. Air has to be saturated for clouds to form. Air has to be saturated for clouds to form. Air is not saturated. Air is not saturated until it gets to dew point. Until it gets to dew point. Again, air has to be saturated for clouds to form. Air is not saturated until it gets to dew point. Question number 3, answer can be found on page 302. Sloping ground lifts the atmosphere. Sloping ground lifts the atmosphere. A denser body of air lifts a less dense body of air. A denser body of air lifts a less dense body of air. Again, sloping ground lifts the atmosphere. A denser body of air lifts a less dense body of air. Question number 4, answers can be found on pages 303 and 304. First row, cirrostratus. Altitude, write high. High. Shape, write thin and flat. Thin and flat. Second row, altocumulus. Altitude, right middle. Shape, it's puffy. Precipitation, no. Third row, nimbostratus. Altitude, low. Shape, thin, flat sheet. Thin, flat sheet. Precipitation, yes. Fourth row, cumulonimbus, low to middle. Shape, puffy, puffy. Precipitation, yes. Question number 5. Answer can be found on page 305. Radiation, the ground cools and the air above cools as a result. Radiation, the ground cools and the air above cools as a result. Advection, the air moves over a cool surface. Advection, the air moves over a cool surface. Again, radiation, the ground cools and the air above it cools as a result. Advection, the air moves over a cool surface.